As we have already completed the topic of bricks, we need to next move for mortar. How we are going to join the bricks? By using motors. So what are the different types of motors available? Cement motor. So cement motor can have proportions of 1:3 to 1:8. So what is this proportion? 1:3 or 1:8? Cement is to sand. So cement is to sand can be between 1:3 to 1:8. So if the cement ratio becomes thicker, that means when less than 1:3, then there will be high drying shrinkage. So you should not use a thicker paste or which is less than 1:3 ratio, then you will have high drying shrinkage. If you use the ratio which is greater than 1:5, that can affect your workability. So it can become unworkable when you have a ratio greater than 1:5, but sometimes it is mandatory that we need to use 1:8, but as you are moving from 1:5 to 1:6, 1:7, 1:8, then your workable conditions will reduce. And next, lime mortar. So 1:2 ratio of cement is to lime. There you have low ultimate strength. You are not going to use it much in your practical life. And the final one is gauged mortars. This is the most important one. Why? Because you will get a good workable with no cracks, with highest durability and strong mortar with this gauged mortars. So in this gauged mortars, what are the proportions you require to mix? 1:1:6 of cement is to lime is to sand, or 1:2:9 of cement is to lime is to sand, or 1:3:12 of cement is to lime is to sand. So gauged mortars are the best mortars which gives you more workability, no cracks, no very good strength and highest toughness and also durability. And we have at different places we use different cement mixture of mortars. So in the interior walls, generally we go for 1:4 ratio of cement is to sand, and exterior walls 1:5 to 6. And pointing. What is pointing? Suppose if there are two walls like this, exactly at the corner we need to keep pointed edges, right? Keeping pointed edges is also a type of pointing is also a type of art. So pointing have a ratio of 1:3 of cement is to sand ratio, and in the reinforced structures you use 1:3 of cement is to sand, and finally in the foundation you use 1:3:4 ratio of cement is to sand. So likewise you can use the different proportions of mortar. So you can copy these proportions and how it is going to affect the different factors are mentioned here. Note down this mortar topic. We are moving to the very important topic in construction materials, that is constituents of concrete. So in the constituents of concrete, the major component is cement. Cement means major in the terms, it is a minor term, but what happens is cement is very important topic for your GATE exams. That's why I am calling it as major component, but cement is the minimum component of concrete. Okay, so cement, what is cement? Cement is a material which have both adhesive and cohesive properties. It is used for bonding of aggregates, that might be small coarse aggregates and fine aggregates. It creates bond and gives strength through concrete, right? So there are two types of cement: natural cement and artificial cement. In artificial cement, we have calcareous and argillaceous cement. We have different types of cement in it. We will be discussing it later. But what are the compositions of cement? In the compositions of cement, we have lime as the major component, which is represented by CaO with 60 to 65%, and lime gives strength and soundness to cement. Okay, so the strength and soundness of cement is determined by lime, but if excess of lime is present in cement, then it causes deficiency of strength and setting. See, it is giving strength, but if it gives, if the lime is in excess in the concrete, so in the cement, then it reduces the strength, and it gives soundness. So what is soundness? Soundness means ability of not increasing by volume. Sometimes what happens when an unsound cement increases by volume, which in turn brings cracks in concrete. So each and every cement should be sound. If the cement is unsound, you should not use it in concrete. So strength and soundness comes from lime, and excess of lime causes decrease in strength as well as in setting time. Next, silica. Silica is also for strength. You should remember this silica for strength deeply. Why? Because you know CSH gel only gives strength. So what is that S? S is known as silica. So as we know CSH gel gives strength, silica also gives strength. Excess of it causes slow setting. Okay. And the next one is alumina. Alumina consists of 3 to 8%, and it gives quick setting time. So when it gives quick setting time, when excess of alumina causes alumina causes reduction in strength. So see, if you want more strength, give more lime. If you want more setting time, less setting time, then go for high alumina. And the next one is ferric oxide Fe2O3. Which is having a percentage of 0.3 to 6%, which gives color and fusion to SiO2. Fusion to SiO2. That means ferric oxide helps silica to burn. So even in the topic of bricks we have discussed, ferric oxide helps to burn silica, right? And later on, magnesia. Magnesia should be 1 to 3%. It gives color and hardness. And excess of magnesia causes unsoundness. And sulfur. Sulfur gives 1 to 3%. Sulfur will be 1 to 3% of cement, and it makes cement sound. Okay. And the alkalis, the minority portion of the cement, this consists of Na2O and K2O and T2O and also P2O. That can be around 0.2 to 1%, and excess causes efflorescence. I have already discussed about efflorescence in the brick chapter, so I am not going to repeat it here. So these are the major components of a cement, like silica, alumina, ferrous, magnesium, sulfur and alkalis. But we know the other terms of this arrangement also. So what are the other terms? That is by using Bogues compound. So let us discuss something about Bogues compounds. So we have 4 different Bogues compounds, right? So what are the 4 different Bogues compounds? Those are halite, baelite, clite and phthalate. Halite, baelite, clite and phthalate. So what is halite? It is C2S, and next C3S, C3A, and what is clite? C4A. So now how we have got this C3A, C3S, C3, C2A and all? C2S is 2CaO SiO2, and C3S is 3CaO SiO2, and C3A is 3CaO Al2O3, and C4AF is 4CaO Al2O3 Fe2O3, right? So these are the chemical compositions, and this is known as dicalcium silicate, and this is tricalcium silicate, and this is tricalcium aluminate, and tetracalcium aluminoferrite. So these are the various Box compounds which are required for the chemical reactions of cement when it is heated with water, when it is heated in presence of water. So now we are going to discuss about the strength and setting aspects of this C2S, C3S, C3A and C4AF when it has mixed with water, that is also known as heat of hydration. First, note down this tabular form. Yes, now the percentage of C2S is 10.8% and this is 16.6%, sorry, 54%. 54.1% and C3A is 16% and this is around 9.1%. This percentages when mixed with water, what happens? It produces some heat. What happens is we have produced cement in some exothermic process, right? So when we have attained the cement, we have got it by heating a lot, right? We have heated argillaceous and calcareous materials at 800 to 1400 degrees centigrade and produce cement. But when you touch cement, it is very cool, right? So, but what it have done, all this energy is stored in cement particles. The heat what we have given, which is used for burning of fuel, all this heat is stored in form of cement, but it comes out only when cement is mixed with water. But if you touch a cement, it will be cool. But when you mix it with water, you will feel it hot. Why? Because that energy is getting outside, right? So now, when I mix this both compounds with water, let us try to know what are the values of mixing of what are the values of mixing of water causes heat in it. The concept is very simple. Now what I am going to do is I am adding cement with water such that I am getting some energy. So how much energy I am going to get? If I add C2S with water, I am measuring it in kilojoules per kg, 260 kilojoules per kg of energy. And if I add C3S to water, then I will get around 502 kilojoules per kg. And if I add C3A to water, I will be having 867 kilojoules per kg of energy. And here I am going to get 419 kilojoules per kg of energy. So see, which is going to give you more energy? Obviously C3A. So C3A is more responsible for setting. Why? Because see, this is giving you more heat. You know, C3A is responsible for setting. Why? Because it is consisting of alumina, and you have read it in constituents of cement or ingredients of cement that alumina is responsible for setting. C3A, calcium aluminate. So it is responsible for setting, and this 867. That means when it is reacted with water, it is moving. It is reacting very fast and with very high energy. That's why C3A is responsible for setting. And you know C3S and C2S, which is the majority component C3S. So C3S gives you more strength. It is a majority component and gives you more strength. But out of the C3S and C2S, which gives you early strength and which gives you late strength? See, just observe these energies. When it reacts with water, it is giving more energy. So it will react fast. So C3S is responsible for your strength, which is attained in less time. So if you go for the long term, then your strength comes from C2S. So C3S gives you strength in short duration and C2S gives you strength in longer duration. And why C4AF is used? C4AF is also used for setting of cement. Okay, so like this, using this Box compound, when we mix with water by the hydration process, C3A is responsible for quick setting, C3S is responsible for strength in less time or strength before setting, and C2S is responsible for the setting for the strength after setting of concrete or after hardening stage. Suppose even cement strength increases daily with age. Even after 2 years, when it has mixed with water, there will be strength increase in the cement paste. So that is due to C2S, right? Suppose if I have mixed cement with water and within 1 hour there is some strength in strength in cement paste, then that comes from C3A. So if I mix some water, it is going to set in 30 minutes. So that comes from C3A. Okay, try to remember these points and note down this tabular form. Next topic is tests on cement. As I said, constituents of concrete is an important topic. In 2019 grade, they have asked you about tests on cement only. So what they have asked you, like Lecture-3 apparatus is used to find dash of cement. So dash of cement, it is soundness of cement. And BCAT apparatus is used to find dash of cement. They have asked you setting time. So like this, they have asked you for which type of test, which type of method is used. So sometimes they might go for the standard IS values also, Indian standard values. So now I am going to discuss here tests on cement with Indian standard values. So now the very first one is fineness test. So what is fineness? So if I do some sieve analysis, where in which sieve maximum amount of cement particles are passing, that defines your fineness. So this fineness test is done by Blaine's air permeability test or IS sieve test or Wagner's turbidity meter test. So when I have done Blaine's air permeability test as per Indian standards, I should get a fineness of 225 meter square per kg for 33 grade, 43 grade and 53 grade cement. And next, soundness test. I have already said about soundness. Soundness test can be done by either Lechatelier test or autoclave test. So if it is done by Lechatelier test as per IS standards, for this 33 grade of cement or 43 or 53 grade of cement, you should get the value of 10 millimeters. If you have done autoclave test as per Indian standards, then you should get 0.8% of soundness. And setting time is done by BCAT apparatus. Initial setting time and final setting time are the important things to know. What is initial setting time? So when cement is mixed with water, then it forms a paste and we cannot deform its shape further. That means it became plastic in the first stage, that is initial setting time. Initial setting time should not be greater than 30 minutes. It should be less than 30 minutes. And final setting time should not be less than 600 minutes. Okay? Final setting time, what happens? Concrete gains its strength. Okay? And compressive strength. Compressive strength is done by compressive testing machine. You prepare 50 centimeter square surface area of a concrete cube and test it in compression testing machine. You get some values. Suppose if you are doing it for 33 grade cement, when you test it for 3 days, you should get 16, and testing it 7 days, you get 22 value, and for 28 days, you should get at least 33. Likewise, for 43 grade, for 3 days it is 23, for 7 days it is 33, and for 28 days it is 43. And 53 grade, it is 27, 37 and 53 for 3 days, 7 days and 28 days. So it looks very simple to identify this. Why? Because see, for 28 days strength should be 33, 43 and 53 as per the names, right? And next, for 3 days strength is generally greater than 1/3 of its strength. So what is 1/3 of 33? 11. So it should be greater than 11. So you can comfortably keep around 15 to 16 value. And here 43 by 3 is something around 43 by 3 is something around 17 plus 5, which gives you 23. So 53 by 3 also, you can find it around 60 60, so you will get it around 23. Then by adding 4, you will get 27. So like this, 3-day strength should be a little bit higher than 1/3 of its characteristic strength. So do you know what is characteristic? Yes. So characteristic strength is just 28 days strength, right? So 7-day strength should be 2/3 of compressive characteristic strength. So if I do 2/3 times, you are going to get it. Around 2/3 times you will get it, and this 2/3 times you will get it. So 28 day strength, you just multiply it with 1. 7-day strength, multiply it with 2/3, and 3-day strength, multiply it with 1/3 and add some value. So like this, there are various tests on cement. You need to remember this Indian standards for GATE exam, as these are important bits. Next topic we are going to discuss here is types of cement. This is also one of the important thing. So you just you just need not to remember all the names and compositions. By just reading the names, you will try to understand what are the constituents in it. So I will explain you in such a way that by knowing the name, you will try to learn it with just remembering this tabular form. Try to remember this tabular form. By using this, we will define all this, how we are going to do it. So first one is rapid hardening Portland cement, right? So rapid hardening Portland cement. What does it say? It is cement should harden rapidly. Generally, it is used in hot weather conditions. So what happens here is water evaporates fast. So hardening water cement ratio, what we are giving, when water evaporates, it's try to have less shrinkage. At that time, we need rapid hardening of cement. So for rapid hardening of cement, which gives you more strength and more, which takes more energy, C3S. Actually, C3A reacts fast, so it will help you to set fast. But actually what happens here is, it won't give you sufficient strength, right? So which gives you more strength, more hardness, that is C3S. That gives you early strength, right? So here rapid hardening, that means it should harden very fast. So which should increase? C3S should increase. So what I am doing is, for ordinary Portland cement, I am giving more C3S. So when I am adding more C3S, what can happen is, there can be flash set or something. So for that, what I will do is, I will add some more gypsum to reduce the fastness, or to reduce the lumps, or to reduce the flash set. So with this composition, I can get rapid hardening cement. Sometimes what happens is, you need jet cement. That means generally you get initial setting time in 30 minutes. Sometimes you need to get initial setting time in 5 to 10 minutes. So then you add, that is jet cement. For the construction of jet cement, you need OPC plus calcium aluminoferrite C4AF plus gypsum, which gives you jet cement. And next, low heat Portland cement. Out of all the cements we have, low heat Portland cement gives you the best durability. It gives you the best strength as well as best durability. That's why it is used in construction of dams and any of the construction of other hydraulic structures. So low heat Portland cement, what do you want? Low heat. Which gives you low heat here? C2S gives you low heat here. But what we are going to do is, we are trying to reduce C3S and C3A here. Why? Because these are giving more heats. I want to reduce the heat. So in low heat Portland cement, I am going to subtract OPC minus some amount of C3A minus some amount of C3S. Why? Because these two are having high heats, right? So here heat was 867 and find out to these two are the highest. So I am reducing them to get the low heat cement. I am repeating again, low heat cement is the best cement for getting best strength and best durability. That's why it is used in mass concrete in dams. And sulfate resisting cement. Suppose if you are having some sulfate resistance sulfate resistance means like when you have some sulfate in groundwater, when you construct a concrete structure, and this groundwater when comes in contact with the concrete surface, the sulfate tries to attack the concrete and forms some adringates and forms expansion of volume. Then it affects the concrete and forms cracks, right? So because of that, we should use sulfate resisting cement where groundwater is polluted, right? So for this sulfate resisting cement, what I have to add is, I no need to add anything, I need to reduce C3A. So OPC minus C3A gives me sulfate resisting cement, and super sulfated cement is used at seashore areas. So what happens at seashore areas, along with the sulfate attack, there can be salt effect also. Because of the chloride and because of the NaCl and CaCl2 attack, along with the sulfate attack, we can use super sulfated cement at the place of seashore areas. So how you are going to get super sulfated cement over here? So for this, you need to add, you are going to reduce cement quantity drastically. For this, you are going to add 80 to 85% of GGBS, ground granulated blast furnace slag, GGBS, ground granulated blast furnace slag, and 10 to 15% of gypsum, and just 5 to 10% of OPC. By combining this, we will get super sulfated cement, which is very helpful for constructions in seashore areas. Okay? Otherwise, it will get affected and corroded, and cracks will be formed very easily in seashore areas because of sulfate attack as well as chloride attack. Next, high alumina cement. You use high alumina cement for fire resisting. Okay? For fire resistance and quick strength, quick setting also, right? When there is high alumina, you will get more heat. That means setting will be very faster. And next, Portland slag cement. Portland slag cement gives you strength slowly, but it gives you the best strength. That's why Portland slag cement is used in mass concrete in dam constructions. So we will use Portland pozzolana cement also in mass concrete in dam construction. How you are going to get Portland pozzolana cement? What is meant by pozzolana first? So pozzolana is simply a chemical substance which came from some eruption. So what is that eruption? Suppose this fly ash, slag and all, which are coming from the eruptions of thermal power plants, or sometimes we may have a powdered ash which is coming out of lava, which is a natural process. This powdered form of slag or fly ash, whichever it is forming, can be mixed with the cement and forms Portland pozzolana cement. This gives you more strength and more durability. These particles are very much finer than cement particles. Do you know what is the difference between cement particle and fly ash particle size? Suppose if your cement particle size is X, then your fly ash particle size will be 1/600 of cement. That means if I have 2 to 3 cement particles like this gap can be filled by almost hundreds of fly ash particles. Right? So when this is formed, I can simply say the pores between cement particles have reduced. When the pores have reduced, it gives more strength. So Portland pozzolana cement gives you more strength, as it is going to have fly ash and slag, which are having minute particles than the size of the cement. So Portland pozzolana cement is also used in mass concrete in dam construction. So these are the various types of concrete. There are other types of other types of cement also. But what happens is they are not much important for any of the gate exams. or any of the other exams. So we have discussed the only main important thing. If you want, you can read those also. And these are the codes which are corresponds to this cement. You need to remember them and the concept behind them. Please note this down.